Hi everyone, I hope you're well. Thank you for joining us today and I hope you've enjoyed the Passivhaus workshop so far. My name is Emma and I'll be facilitating this session today. I would like to welcome everyone to listen to Alan Budden from Eco Design Consultants, and he'll be talking on comfort benefits and the performance gap of a typical house. Before we begin, I'm sure a few of you have used Zoom already today, but we do have a Q&A function for you to use. That's at the bottom of the screen in the middle, and at the end we'll have a short time to answer any questions that you may have. If all your questions don't get answered during this session, then we do have a 3 p.m. question time session, so any questions that you have you can save till then if you wanted to, and speak to the other panelists as well. I also like to mention that this session is being recorded today, so very soon you should hopefully receive a link so you can watch this session at a later date if you wanted to. I'm also just going to launch a poll that Alan would like to see what audience he has today and who he will be presenting to. So I'll just launch this now, bear with me. So, okay, there you go. So if everyone can please select your answer on the poll. We'll just give that a couple of seconds for everyone to answer. Okay, nearly there, got a few. I think they've just joined. So a couple more seconds. Okay, so there we go. So the question was, which is the most important to you to feel comfortable at your home? And the highest one we've got is the right temperature, so that's 31%, and an even temperature at 25%, and also good air quality was up there as well with 25%. Okay, thank you very much. Okay, Alan, if you'd like to unmute yourself and share your screen.
Hi Emma, thank you for that.
Hello, you're very welcome, and I shall leave it over to you now.
Excellent, thank you. So welcome everyone. I'm going to share my screen now. I'm just hoping just to check Emma this is working okay. Share screen, slideshow.
Let's have a look.
Okay, is that now visible?
Yeah, that's great. Thank you, Alan.
Fantastic. Okay, thank you, Emma. Okay, so welcome everyone. My name's Alan Budden. I'm from Eco Design Consultants, a practice of architects who set up, basically I set it up just over 10 years ago now, looking at eco homes in particular, and in particular Passivhaus, and be involved with Passivhaus pretty much all the time with Eco Design Consultants. We're doing a number of projects, both new build and retrofit. Okay, so let's get going. So this is about comfort benefits, a guide to the performance of a typical house and looking at the performance gap. So these are a couple of projects we've done. So this house we did quite a few years ago now, which was the most airtight house in the country until fairly recently when it was just beaten by somebody else. We've also done a number of retrofits to the Enefit standard and Passivhaus retrofits to full Passivhaus standard, and this one here, a Passivhaus Plus with PV integrated into the roof to provide the owners of the house energy for the whole house, and even charging an electric car. So they actually have energy credit rather than bills, so they actually get money from the energy suppliers. Okay, so thank you very much for completing that poll earlier. So what is comfort? I think that's the first question. If I looked it up on the Oxford English Dictionary, and it says it's a state of physical ease and freedom from pain or constraints. So that's the dictionary definition. So the poll, which you've just all filled in, there's no right answer here. It's interesting to see which ones people did fill in. So the right temperature being one of them, but an even temperature is also just as important, and no drafts and good air quality. So all these things are very important, and each one is quite personal. One of the things you'll find is that different people have different temperature things. You've probably seen this sort of thing. Comfort is very personal. So you may feel very hot and your partner may feel very cold. So you're often fighting over the temperature, the thermostat and things like that. So it is very personal, and it can change from country to country and from winter to summer and the seasons. So it is something that changes, and it's very difficult to have something that's comfort that meets everyone's requirements. I think what it is, I think it's about adapting to that comfort. So within a few degrees of temperature, you can very easily either put a jumper on or take it off. So that's the way you really should be looking to adapt to a building. Passive houses are very good in terms of getting a very even temperature and keeping it at a very constant temperature. But obviously the difference in personal requirements could be slightly different. So you might decide to put a jumper on or not. So yes, so it's very personal. I mean, the other big thing, which I think probably for those guys who watched the presentation this morning, I'm sure this slide was brought up, looking at the performance gap. So what this slide shows is some co-heating tests, some tests done on existing houses. And the blue column being the predicted, so that's what's done in the energy modeling software, and the red being the measured. And as you can see, there's a huge difference between them. I mean, this is kind of, I think, the next Dieselgate coming through in terms of what people are expecting the houses to perform and to actually what they do perform. And these ones down the bottom here, they're the passive house ones. So very, very much closer to the predicted, and very little, very, very low anyway. So the percentage difference becomes maybe higher, but the actual difference is very small. So passive house is really good in terms of making sure that that gap is small. What I wanted to do today really was to go through a number of issues which are passive house principles. They are about trying to make your house as comfortable and as healthy as possible. These are principles that can be used on both new builds and retrofits. So the house you're in at the moment and maybe your future home or your retrofitted home or whatever. So these are principles that can be used throughout. They also are, I'll be picking out the ones that I think are particularly important in terms of if you go back to the slide, where I think some of these differences are being made and some of the issues that are kind of making some of the other constructions not quite as good as passive house in terms of the performance. So what we have in our company really is our 9-point guide to comfortable, healthy home. So these are kind of some of the 9 principles. Some of them are passive house, some of them go a little bit further. So number 1, insulation. I'm sure you all know about that. So basically that's about having a big duvet of insulation over your house, wrapping up nice and warm. As you know, these slides are being recorded, so some of the top tips you might want to come back to. So if you look at the recording, you can see those. So top tips here: making sure it's continuous, no gaps. Often we suggest using a softer insulation. It fits easier, so you can make sure there's no gaps between them. If you have a rigid board, when they butt up, there could be a little gap. So soft, they're not usually as well performing, so you'll need to have a slightly thicker insulation as well. But when you're buying it, do look at the performance. Do look at the thermal conductivity or the lambda value. This is the thermal conductivity. This really makes sure you get the better stuff. Loft insulation in particular is one of those things you can get in all sorts of performances, from 0.046 down to 0.032, almost a third as good on some materials. So when you go around B&Q and stuff, look for those numbers and try and get as low a number as you can. Number 2, which in some ways I think possibly should be number 1, is the efficient shape. So this is about making sure your house is as efficient as possible. I'm sure other people have been mentioning this in the workshops. basically, if you take a mid-floor flat and a bungalow and you can compare the two, you open them up to see where the heat loss area is. The mid-floor flat here has a heat loss area of 74 meters squared, exactly the same layout and size of the unit for the bungalow, which have 279 meters squared of heat loss area. And if you compare those two things, you start looking at your form factor goes up from the mid-floor flat, which might have a form factor of about 0.7, to the bungalow with a form factor over 3. This isn't the Passivhaus form factors. This is from a document that we produced for the NHBC Foundation, which is using SAP, so slightly different numbers here, but the results are the same, really. So looking at the mid-floor apartments, a specific heat demand of 2,000 kilowatts per year, and the bungalow 4,500 kilowatts per year. So you can see quite clearly that the bungalow is using over double the amount of heat with exactly the same amounts of insulation and windows and everything else is identical, just the increase in floor area, heat loss area, sorry. So some tips there: keep your building as simple as possible and compact. And if you're going to have fairly small properties, maybe put them together, cuddle them together. So have terraces and things like that. Those sort of things can make a huge difference and keep the cost of the building down. So this is something that I'd really encourage as a first step to designing a new house, to do that. Although if you're looking at an existing house, maybe look at taking out some of those recesses or those projections. Moving a recessed front door out to the surface of the house can make quite a big difference. And this is all in a document called The Challenge of Shape and Form by the NHBC Foundation, which we helped to co-author. And it's available for free to download from the NHBC Foundation website. Number 3, thermal bridges. This is where you might have a sleeping bag, and the old ones used to have metal zips, and I remember rolling over in the night and getting that metal zip and finding it rather cold. So trying to avoid those metal zips and those other things that go through the insulation. So keeping your insulation continuous with no bits and pieces going through it. In a building terms, that often would be potentially a piece of steel or a piece of concrete or something that goes from the outside to the inside and will allow the heat from the inside to go straight to the outside and keep a very cold surface on the inside, which could then potentially cause condensation and mold and other things. So very important, as well as heat loss, to keep those thermal bridges as low as possible. So continuous insulation, and yeah, if you're doing things like a lintel over a window, try and split them. Maybe put a lintel on the outside leaf and one on the inside leaf if you're doing a cavity wall. So simple things like that, trying to keep your structural elements either inside or outside of the thermal envelope. Number 4. So again, these sort of thermal bridges aren't things that are necessarily picked up in building regulations and other things. So these are the type of thing that might make a difference in terms of your performance of your building and the performance gap in terms of quality of build. Number 4, which I think is one of the biggest things in terms of the performance gap, is the drafts. In a building regulation house, you can have an air tightness and air permeability up to 10, and that's the equivalent in a 3-bedroom house of a hole that big. So that's the size of hole that you could have left open all year round, letting in the cold air. Obviously, it's not just one big hole, otherwise you would have closed it. It's lots of little bits all over the place. It's kind of from around windows, first floor junction, around service penetrations, around the ceilings, and all sorts of areas where you're leaking air. And that leaking air is also bringing in other things. It's bringing in insects and dust and all sorts of things. And also warm, moist air might be going out via those holes as well. And that might then be condensing, which could cause timber to rot or to swell or to mold and all sorts of things. So keeping your house very draft free has lots of benefits, to be honest. So the top tips in terms of trying to keep your house draft free would be having a continuous air tightness layer, attention to detail, and using the specialist tapes. These are tapes that will last for 50 to 100 years. Keeping it draft free, often people think if it's a airtight house, oh, that must be horrible. you're going to go into this, they feel it's like putting a plastic bag over your head. Not the sort of thing I'd recommend doing. It's much more like putting a Gore-Tex coat on than that will breathe and will allow you to the house to breathe and to air to move through it. But it won't let the moisture backwards and forwards. It's very, very clever stuff. So it's really like a Gore-Tex coat rather than a cagoule. So if we look at some of the numbers, this is some stuff we did in PHPP, the Passivhaus planning package, and we looked at a passive house to start with. So an air tightness of 0.6 air changes per hour. And you can see the red bar here, that's the losses from drafts from infiltration. If we change that number to 10, which is the backstop in building regulations, that red bar gets much bigger. And as you can see, the heating load, which was 14 kilowatts for the per square meter per annum for the passive house, then goes up to 66. So that's a considerable loss, as you can see. So it's really, really important in terms of reducing your energy to get the drafts out of the building. That helps in a huge way. And it's one of the probably the more cost-effective ways of doing it, because you can keep adding more insulation, but these bars are going to get a little bit less, but it's not going to have such a big drop as keeping it getting your insulation, your infiltration down, your drafts down. This is something that I personally think is one of the big areas of the performance gap, and the building regulation requirements on air pressure testing isn't as robust as the passive house ones, where you need to do both a positive and a negative test, and you take the average, whereas building regulations, you can take a positive or a negative, and you can take whichever one is better. And also, if you're doing a big estate of houses, you don't have to do an air pressure test on every house. You can have a typical house, and that will be counted for a number of other properties. So you can imagine the builder will spend more time getting the air tightness right on that one they're testing than the other ones. So there's lots of reasons I think the performance gap is related in quite a large way to the air tightness. So same top tips as before. So moving on, number 5, good ventilation. So you've got that nice airtight building. You then need to have an efficient MVHR that's designed well and installed well. Building regulations has all sorts of things that allow you to put MVHR units in the loft in the cold, and then the only thing they worry about is the insulation between in the loft space. They don't worry about the uninsulated duct lengths coming from the outside to the unit, which again is really important to keep those duct lengths between the unit itself and the outside, keep those really short, because that is heat loss area. So yeah, so mechanical ventilation heat recovery really good. I guess you guys have watched already presentations on this. If not, there's some good ones to go back to have a look at. Top tips here. I would suggest not putting it in the loft. You could put it in the loft if you wanted to, but you've got to think, okay, I need to have a look at those filters, maybe change them once a month and check they're all right. If it's in the loft, will I do that? Maybe not. What happens when I get older? Can I actually get physically into the loft okay, safely? Maybe not. So put it somewhere that you can access it. Like I was saying before, put it on an outside wall so that the inlet ducts and the exhaust ducts are as short as possible, because that is external air temperature within those ducts. So you want to keep those as close to the outside and those ducts as short as possible. You will insulate them, but still you are losing heat there. And really importantly, commission them properly. Make sure you get somebody who knows what they're doing to install the MVHR and commission it. You want to get the outlet valves and the inlet valves balanced correctly, so there's no mismatch in terms of flow rates, therefore no noises between machines. The machine won't be working too hard, it won't be over ventilating or under ventilating. So very important to get that done correctly. So good ventilation. One of the great things with that is, I think, is the filtering of the air. So this, again, in terms of comfort, is really good in terms of filtering the air. This was a slide taken from the Tesla car, and what they did was they looked to see how the filters in the car were working in terms of biodefense. And so they filled this dome up and they put in various nasty chemicals and stuff, and to check what the air quality was inside that car, and it was good. And what they found was the air quality outside slowly got better. because of the filtering system within the car. I think your MVHR is relatively similar to that. So if you get a very airtight building, you can use the filters within the MVHR to help filter the air, so you're going to be much healthier inside. So make sure, again, you want to make it well-designed ventilation system. You need to make sure you've got good sound attenuators and it's designed correctly. And you want to make sure that the ducts are large and smooth. I would always recommend the galvanized metal ducts over the semi-rigid and the flexible ducts. I feel that they're going to last longer and are better. And because there's fewer of them, not necessarily more expensive to fit. Number 6, good windows. The windows are really important. I think those of you who just listened to Paul's slide just now, you'll understand how important windows are. They're really, really important. So you can use them to let the sun in and keep it in. As I think Paul probably mentioned, was that the body can detect 4 degrees difference between inside and outside air temperature. So keeping that, having triple glazing will ensure that that 4 degrees, even if it's down to -1 outside, will be kept. The double glazing, you're going to get sort of 5 degrees difference, triple glazing down to 3 degrees difference. So some good windows are really important in terms of keeping the temperature right. And if you have that, you don't then need to have radiators under your windows. So I would always suggest triple glazing. It's not that much more expensive, particularly if you've got good windows. It's relatively little add-on really in the scheme of things. But do always make sure you still have the argon and the low E coating, and also look at the G value, which is the solar gain, and adjust those accordingly depending on size of windows and overheating and all sorts of things. This is another slide that I used to do some teaching at Birmingham City University to the architecture students, and this is a slide from them. They're looking at 3 windows and making sure that you look at the frame factor. So window B has 13% more losses than window A, purely because of the extra frame. And window C, 32% more losses. Window A is also cheaper. So, which I think Paul would probably have told you. So yes, so try and make your windows as large as possible with as little a frame to glass factor. So that the frame factor is how much percentage of frame to glass. So keep that amount of frame as small as possible, because the frame is the weakest point in the house. So again, this is by keeping those areas down, it keeps the comfort up, and it keeps the building nice and warm, and there's no drafts from those cold surfaces. Orientation is good, important, but the shape I feel is more important. So a good shape would trump the orientation, and definitely insulation trumps passive solar. So trying to use lots of passive solar to heat your house can work, but the weather can change and it can be used wrongly in terms of solar buffer zones and all sorts of things. So insulation is really the way to go. It's reliable, it works. Yep, so large windows and less divisions. A lot of this is in another document that we produced for the HBC Foundation on windows, about making it clear that looks at the differences between overheating, glazing uses, energy loss, and daylighting. Number 7, keeping cool in summer. This is probably one of the bigger comfort issues, and I think it's an issue that's beginning to become more and more with climate change, which unfortunately doesn't look like we're doing what we need to do to stop it. So it looks as though we are going to have increased temperatures. So it's going to become more and more important. We can use building physics to try and reduce the overheating by having large overhangs. So in summer, we can have an overhang that shades out the summer sun. And in winter, when the sun is lower, we can let the sun in. This is one of the really good things about, if you can, is face your building south. That allows that winter sun in and shades out, because in summer, the sun is the highest in the south. So that's the easiest side to provide shading. That's yes, orientate south if possible. The other thing you really want to look at is opening windows. So do have openable windows in all your rooms so that you can open them and let the hot air out if you need to in summer. And also, if you can, allow some cross ventilation. Maybe even look at a high level window at the top of the stairs to let warm air out, and the low level windows lower down to let heat in. So that stack effect can also help a little bit in terms of ventilation. One of the important things here is to not overglaze. This is a fairly common view now. I think a lot of architecture is looking to more and more glazing, because having lots of lovely glazing is really sexy and looks really good on some buildings. But I do wonder whether in some places glass is used where it shouldn't be. Like you can see here, there's not enough storage, so you start putting things in front of the window. This isn't a great view from the outside of the building, as I'm sure you'll all be aware. So do look at where you're putting the glazing and maybe be sensible. If this was just a window at the top half, that would be just as good in terms of getting the daylight into the room. It would lose less heat, it would get less overheating in summer, and it would be cheaper. So do look at how much glazing you're using. Yeah, thank you very much. Moving on. So the other way of looking at the summit is to shade it out, like I said, having the sun overhangs and stuff. So if you're going to have shading, then use it. And I often think that if you start to want to have to put things like blinds on the outside of your buildings, then kind of the architecture and the building's failing. So you really want to try and design it out in the first place. Keep those windows smaller. Don't, unless it's really, really important and really nice to have that big south-facing window. Yeah, try and avoid the needs for shading. Number 8, so this moves outside the Passivhaus requirements really, and I think is very important. So if you start looking at healthy materials, so if you can, try and pick materials that are healthier. So look at the insulation materials, maybe ones that don't off gas, maybe look at natural flooring materials like linos and real lino and rubber and things like that. Look at your paints, see if you can use paints that don't give out chemicals. Those sort of things again will make your building much healthier. Again, this isn't part of Passivhaus. So yeah, use long-lasting finishes. Number 9, good design. Again, this is kind of outside of the Passivhaus things, but again, I think it's really important. So make sure when you're doing your designs, you find someone who's using the Passivhaus planning package, model the building, see how it performs, use that information to make sure you can optimize it. Look at the daylighting. Again, lighting is really important. Acoustics is good as well and useful. So do all these sort of things. Make sure you're spending the time, and the designer has the opportunity to go as far as they can to do all those things, because these sorts of things will help the comfort of your building, not only your mental health, but also provide delight and also potentially also help on your pocket. So do all those sort of things as well. And it's really good. You need to make sure that the designer, again, understands the local environment. These are kind of some of the stuff that we do in terms of our brief taking, really trying to understand exactly what it is people are after in terms of their performance of the house, whether it's about the environment, whether it's about comfort, capital cost, health, design quality, maintenance, all sorts of things. So do look at those things and make sure that they're looked at in local context and it's ready for the future. Yeah. Get an architect who listens and will understand you and you get on with, and don't skimp on the brief taking. It's really bad if you start to have to go back and redo things later on if those things aren't looked at early on. Yeah, and also make sure that they're technically competent. I think as you get more and more experience of doing Passivhaus, there's more and more things you know and learn. It's a constant learning exercise. So we do lots of analysis. We split all the walls down, and we actually do graphs looking at different types of insulation thicknesses and different types of insulation and comparing them. So it can really help provide really huge amounts of data in terms of really helping to optimize your building and make it best for what you want. And then moves on to sort of project management. Make sure it's really smooth on site and on budget. So really, all those bits and pieces come together towards the Passivhaus standard, all those comfort areas. So you have the extra insulation, so that obviously makes it more comfortable. you have the efficient shape, again, making it more comfortable in terms of making sure there's heat loss and more comfortable on your pocket in terms of the cost of doing stuff. The triple glazing, again, making sure that the surface temperature within the building is within 4 degrees. So that, again, is the comfort. Airtight, so making sure there's no drafts, again, comfort again. And it's really important, again, these are the areas which I think are a lot of losses in terms of performance gap. Efficient ventilation system, again, making sure that all works and carries on working. Again, bit of performance gap losses in there, I think, with other systems. Particularly if it's not commissioned correctly. Making sure you get rid of those cold bridges. Again, maybe they're not defined as well and not always calculated correctly in other systems. That all gives you high comfort levels. And all that basically gets you down to the Passivhaus. So from building regulations at 85 kilowatts down to Passivhaus at 15. So it's just about chipping away little bits and pieces to make you get to the best you can get, really. A very low energy usage. And the result is basically very happy people. These are the clients of the house we showed at the very beginning slide. They're very happy in their new house. Not only are they nice and comfortable in terms of the internal environment, they're also nice and comfortable because they're getting an income from the house rather than have to pay bills on heating bills. So a win-win. It's interesting now at the moment with sort of the coronavirus and going forward, it looks like the interest rates are really, really low. So I think now is the time to invest in these extra things. So if you invest in the extra insulation and the air tightness, that will pay back in fuel savings going forward. So I would highly recommend doing it at the moment. One of the things with the Passivhaus training is you look at the costs of Passivhaus. So okay, it will cost you a little bit more to build, maybe 5 to 10% more. But you also look at that money I was going to spend on the Passivhaus, where do I spend it elsewhere? You need to take into account the interest you would receive on that. So at the moment, that's pretty low. So your payback period is going to be quite low and quite short in terms of the Passivhaus at the moment compared to other times. So yeah, so top tips: you want to get a good team. You want to get people who understand Passivhaus and the design and the architecture and everything, and put it all together. And that way you can get a very good Passivhaus. Okay, thank you very much for that. So I think we've got about 14 minutes or so for some questions.
Yes, Alan, we've got a few questions, so I'll just start off for you. Bear with me. So let's go to the first one from Eugene. So I'd like to ask about bathroom heating in a Passivhaus. The previous presenter said that the goal of Passivhaus was one zone of heating at, say, 20 degrees. But stepping out of a warm shower, where by convention I don't wear a sweater, is distinctly uncomfortable. So how can I have a bathroom heated to a higher temperature?
Okay, you can. To be honest, I think at 20 degrees you're not going to get cold. So I think you'll be perfectly fine getting out of your shower at 20 degrees. I don't think I've got any clients who have any issue there. What we would generally do, to be honest, is in heating Passivhaus is one of the zones that you probably want slightly warmer than other areas. So we would generally put in heated towel rails in those areas, so it will be slightly warmer. And again, you can dry and warm your towels in that area as well. The other great advantage of Passivhaus is that your towels will dry really quickly. And in your bathroom, you won't have mirrors that steam up. You won't have any of those issues. Those issues go away. We had a rep phone us recently trying to sell us some extract unit above your shower to stop the windows steaming up. There's no need for that. That all goes away. It would be a non-issue, I'd say.
Okay, sorry. Brilliant. No, thank you. That's great. Okay, so a question from Anthony. So it's on grading a Passivhaus. So if you build a certified Passivhaus classic house, but perhaps save for renewables so that they can purchase them when the funds are available later on down the line, can they recertify to a higher level? Yes.
Yes, you can. In fact, the house here, we were hoping to try and get to Passivhaus Premium, which is higher than the Passivhaus Plus, We were quite close to it, but we were restricted on the amount of power we could put into the local grid. So that stopped us. In the future, we are looking at potentially the owners of the house buying some shares in a new wind turbine, which you can also use to get to the Passivhaus Plus and Premium, and then recertifying. So that is a possibility when we find some suitable shares and stuff for them to buy. So yes.
Okay, I think we've got time for a few more. So here's quite a specific one from Rob, but my builder control officer is telling me that the air tightness value for a passive house is not the same figure as required for building regulations. What's the difference?
Yep, he's quite right. There's building regulations is air permeability, which is measured in terms of surface area of the building, whereas passive house is air changes per hour, which is related to volume. The numbers generally are fairly similar. So it is one that can be easily confused, and you can convert between the two. So they are different numbers. And when you get your air pressure test done, you'll have both numbers on the certificate. So they are fairly similar, but they are different. If that makes sense. It's volume and surface. It's different.
Brilliant. Let's have a look. What else have we got? So here we go. So how far can I go with improving my existing property? It was built in 2002 with good levels of insulation and double glazed wood frame on a cost benefit ratio, say over 10 to 15 years time scale.
You can go as far as you like. We've done it to full passive house. We've done conversions, and we've got a couple on that we're working on at the moment in Oxford and South Oxfordshire, where we're taking existing houses and we're getting to full passive house on them. So you can do it. What I think it's important is get someone to do the PHPP on it, and then you can analyze it and you can look to see what makes sense, because it may be that you've got a very poor form factor, maybe very poor orientation or big windows or small windows or whatever that make it more tricky for your house. But there's always things you can do to improve it. And so you can use the PHPP as a tool to chip away at those little items. It may be you can do it over a period of time as well. It may be that you have a plan, a long-term plan for the house, and you do little bits at a time. But you've got that plan, so you do things that sort of join in with each other rather than then have to redo things. If that makes sense. So yeah,
Okay.
no, get into PHP and find the answers. It's numbers. It can help you.
No, brilliant. Thank you very much. We do have a few more questions, but they're more on heat recovery and MVHR.
Okay.
So I know that Clarissa's doing a talk next, isn't she, on those? Okay. So do you want to answer them, Alan?
I can do if we've got time. Oh, are there any other questions you want to do first and then maybe come back to that, or?
Let's just have a quick look. I don't think there's quite specific ones there. We've got what are the main areas where performance gaps occur?
Okay, yeah, I think it's the air tightness is the big one. I think there's so many stories I hear about sort of building regulations and how it's done. I've heard stories of air pressure tests being done with mastic around the ground floor, around the skirting boards, and as the air tightness person is leaving, the carpet fitter's in there with a standing knife cutting out the mastic. We've had air pressure tests done on existing houses. There was a new air pressure test unit coming out with a pulse test, and all the guys in our office had it done on their house. So they had a blower door test and a pulse test. And I always remember Katie's house, which was a new build. I think it was 3 years old. The EPC said it had an air permeability of 5. The actual result was over 10. So you kind of think that's huge. And when you start looking at how much losses around there, that's one of the big areas I think it is. And I think it's also other attention to details. It's also things that get changed. I think you can find that people are specifying windows with a certain U value and stuff. And then when it gets to site and it's built, these are different windows. And there's no quality assurance, which is great. I mean, that's one of the great things about Passivhaus and the QA process. That those things get checked. And if it's not right, they get put right later. So I think it's that part of it's the QA checking, it's the attention to detail, it's the air tightness. There's so many things there that kind of just tick lots of boxes to make sure it works. That's what I'd say.
Okay, good, thank you. I think we've got time for one more. So this is, oh no, we've got some more coming through. Okay, this one's quite a good one. I think a lot of people do ask this also in the previous ones as well. So how do Passive House cope in the hottest sunny days?
Ah, yes.
Is the temperature inside still comfortable? Can they still get unbearably hot like regular houses?
They can. Passivhaus does have a requirement to try and reduce the overheating down to less than 10%. We would always recommend less than 5 or even less than 3%. With climate change, this is going to become more and more an issue. There is a temptation, I mean, like the image, I'll put my screen back on. There is a tendency to try and overglaze, particularly if you've got lovely views like these guys have had. So there's things you can do, like in here, you can actually, there is a blind that can come out in summer. So that can be extended out to reduce some of the solar gain in summer. So it has been calculated. It was getting towards the limits on this one, to be honest, but you should be able to design it cleverly to reduce that summer overheating. And don't be tempted to do too much glass. That's the real trick. And it's all down to orientation, I think. So yeah, you need to really get a good designer to work hard and make sure it works.
Okay, brilliant. Let's have a look. So here's one as well. Could you design a passive house with underground parking? And if so, could the house above still meet certification requirements if the basement parking didn't?
Yes. No, you just need to make sure that the car parking ceiling stroke the floor of the house was insulated and airtight. Yes, it's quite common in Germany and other parts of Europe to have a unheated basement. In that state, in the UK, I probably wouldn't recommend doing that because it's very expensive. Getting rid of all the soil that you've dug out and doing that, I would really try and avoid basement parking if at all possible, unless you really need to, because you'll find it incredibly expensive.
Okay.
Yes, you can.
Thank you very much. Following on from, so Rob asked a question. Let's have a look. So he's just following on from his question earlier about the building control officer, the question about the air tightness value. Mm-hmm. He's just followed on from that, and he has said, so we have full planning permission, but not yet the PHPP. Mm-hmm. Is it now too late to go passive? What would be the next step for them?
No, it's never too late. It's better to go as early as you can. But the next step would be to get somebody like us to run the PHP numbers, put it in, help optimize it, tweak it around and change it. If it could be that you find a real overheating issue, in which case you may want to go back to planning because you want to change the windows and make them a bit smaller. That sometimes happens. You might want to tweak other things, but you can usually go back to planning and get minor amendments done fairly easily if needed. But a lot of it is down to how thick you have the walls, what type of insulation, what type of windows. Again, with the overheating, there's other things you can do to reduce that. One is reducing the size of the windows, which is always a good one because that saves you money. Other things you can do is change the glass specification. So you can change the G value by putting coatings and other things and films on it to reduce the solar gain. You can look at various shading options. You can also look at ventilation, so looking at cross ventilation and how you can open windows of both sides of the house and all that sort of stuff. So there's a number of tools you can do. So yes, put it into PHPP now, and then you can optimize it. And you don't necessarily need to go to full passive house if you don't want to. You can just use it as a tool to help make your house much more comfortable. And it may not even cost you more money, depending on what you do. Changing a shape could save you money.
I'm sorry, your sound went there, I think, a little bit.
Okay, sorry.
Oh, no, that's all right, thank you. So it's 2:45 now, so we will leave it there. So if anyone has any other questions, we do have question time at 3 o'clock, and Alan will be a part of that as well. Yes. So if you have any more questions for Alan, please save them till then, and you can ask him on that panel there. So thank you very much for that, Alan. That was brilliant. Okay. And if we all enjoyed that, and we found it very informative. So thank you very much.
Yeah. So
sorry, Karen.
So one quick thing I was going to say, if those MVHR questions don't get answered in the next session, bring them to the end. Yeah. And also, if people want one-to-one sessions, then get in touch with our website and myself, or email me, and we can arrange a one-to-one Zoom discussion about your projects.
That's brilliant. Thank you very much. That's great. Thank you very much. So our next session will be on why is efficient heat recovery and ventilation key to good indoor air quality and energy savings in a passive house. And that will be presented by Clarissa from Total Home Environment, and that will be at 2 o'clock. So thank you very much, Alan, and we'll see you later on at 3 o'clock.
Thank you, everyone.
Thank you, everyone. Bye-bye.
Bye.